Welcome to the third episode of our series on building a career in Python. Today, in this episode, we're going to be delving into the world of object-oriented programming. We are certainly stepping up a notch in difficulty for this video, so make sure you have caught up on this series and have watched the last video on control structures. Object-oriented programming is so important for coding. It enables the structuring of code using classes and objects for better organisation. The code is therefore much more readable, and understanding object-oriented programming for libraries and frameworks is important for what we are going to be going into later in the series. We shall be going through the concepts of classes, objects, attributes and methods, and I'll also be showing you how to use these in your Python algorithms. Objects are entities created by classes and are an instance of that class. They have their own attributes and methods linked to them. We think of a class as the blueprint for objects. It will define the methods and behaviours that each object will have. Attributes are properties or characteristics of an object. Attributes have multiple names that can be used, for example, data, fields, memory variables, and properties. Methods are functions of the object that define the behaviour. Alright. So let's jump into the coding, shall we? So first we're going to define a class. To do this, all we need to do is use class and then the name of the class followed by a colon. Now we have created a class called, for this example, person. Now let's create an object for this class. We do this by setting the name of the object, for this example is Daniel, to the name of the class. So now we have an object called Daniel for the class person. Perfect. So now we have done that, we can move on to creating attributes for the objects. We do this by using a function. So to create a function, we use def. So Python knows that this is a function followed by the name of the function. For this function, we are initializing the class. So we use underscore underscore init underscore underscore. And then what variables we would like to receive. We want the people to have attributes being their age and favourite sport. So we receive the variables age and sport. We will also place self in there for the object. So when we use self.age or self.sport, it will map to what object we are currently using. So we can then set these attributes by using self.age equals age and self.sport equals sport. And now we have every object will have two attributes associated to it. So now to use these attributes. The name of the object, Daniel, equals the class, then we give his age, 22, followed by his favourite sport, football. So now we have an object called Daniel for the class person, who we have attribute age and sport, that is 22 and football. We can print these attributes by doing Daniel.age. For example, this will print out 22. And we can also have multiple objects for a class. So let's introduce an object called James. He is 40 and his favourite sport is tennis. So now we can also print out James.sport, which will give us tennis. Amazing. So now we have got a class with objects and attributes. Let's get started on some methods. So these are the functions for the objects. So we use a function, let's call the function change sport. We would like to receive self and what the new sport we would like to change to. Using self.sport equals new sport, we now set the objects to the new favourite sport to the variable we have just received. So we are going to use Daniel once again. But Daniel has now decided that his favourite sport is now cricket. So we call the change sport function by doing Daniel.changeSport and then in brackets, cricket. So now we have changed the attribute, so when we print Daniel.spot, it will say cricket instead of football. We can use methods to do anything of an object. Now, that is the start of object-oriented programming. Now we're going to need to investigate inheritance. What we need to understand is the concept of superclasses and subclasses. It is easier to show you than explain it, but the subclass will inherit characteristics of the superclass. and therefore the subclass can add features to the superclass. To begin with, inheritance. Let's start off with a single superclass and a subclass. So let's create a class called sup. This will be our superclass. Inside of this, we are going to put in a function that will just print I am in the superclass. Then we shall create another class called sub. This will be our subclass. We can make sub be a subclass of sup by placing sup in brackets after. We have now made sup a superclass and sub a subclass of each other. Sub is going to print out I am in the subclass. We will now create an object for the subclass. We shall call class1 equals sub. We will call the method inside of the subclass, example2, and it will therefore print I am in the subclass. Now we will call the method example1. Notice how there isn't a method in the subclass called example1, so therefore it should come up with an error, since the function doesn't exist. However, since the class is a subclass of sup, it will then check the superclass as well. It will find the method example1 in there, and therefore it will print I am in the superclass. So we can see that if a subclass doesn't have the method, it will check the superclass for the method. In this quick example, we shall do the same thing, but this time the functions are both called example1. In this case, when we call example1, it will not check the superclass since we have found the method already in the subclass, and therefore it will just print I am in a subclass. So that was just a quick example of what would happen in this case. We can also use inheritance on multiple superclasses, so a subclass can have multiple superclasses. To show this, I have got 3 superclasses, sup1, sup2 and sup3, all of which will print out what class they are in. Now, in order to make the subclass have these superclasses, inside the brackets we put the name of all the superclasses. We will be putting these in order of what superclass we want to check first. So I've put the subclass, sub, with the superclasses listed from 1 to 3. So now if I've set an object called class1 to the subclass, if I use example1, it will check the subclass for example1. It cannot find it. So now it will check sup1. It has found it, so it runs I am in the first class. For example2, it will check the subclass, doesn't find it, check the sup1 class, doesn't find it, and then checks sup2, finds it, and therefore prints I am in the second superclass. Perfect. And for example 3, it will print I am in the third superclass, and for example 4, it will print I am in the subclass. Perfect. So those are what you need to know about inheritance. There is now a function we are going to be using called the super function. When this function is running, it will send the program to the function given inside of the superclass. So let's check out this example. We shall create a very similar example to our first on inheritance, with a super and a subclass that print what class they are in. But this time we're going to place in the super function, super brackets dot example1. Now when we run example1 inside of the subclass, it will print I am in the subclass, and then it will run the function as well. This will send it up to the superclass and run the function. So for this, we want the function to run example1, so therefore when we run example1 inside of the superclass, and therefore it will print I am in the superclass. So now when I run it, it shall print both I am in the subclass and I am in the superclass. Perfect. Let's add a few more superclasses into the mix. So we have another similar example here with the addition of a super function. Since we are looking for the function example 4, it will scan through the subclass. Find the function example 4 in there, then it will run print I am in the subclass. Following from that, it shall run super example 1. It will then check the first superclass, sup1. It finds example 1 inside, so it runs I am in the first superclass. It will then run super.example3. It will check sup1, it's not in there. Check sup2, it's not in there either. But then it will check sup3, finds the function in there, and therefore runs I am in the third superclass. So when we run this code, we get I am in the subclass, first class, and third class. Amazing. So one key concept you're going to need to know is encapsulation. You will have private and protected members. In protected, you can access data in the class from inside the class or subclass. Now in Python, you can access a protected member from outside, but it is generally convention that you don't. And private, you can only access data in the class from inside of the class. You can do this by placing 2 underscores before the variable, and now it is private. Let me show you an example of this for now. We will create a superclass with attributes underscore A. This will be the protected member, and underscore B. This shall be the private member. I have now also created a subclass that when initialized, it will send to the superclass and store the attributes. Following from that, it will attempt to print out both of these attributes in the subclass. Now, when I run this code, it will print out protected member. However, then as we try to print underscore B, it will fail and come up with an attribute error. This is because the subclass cannot find the attribute due to it being a private member, so therefore showing that you can only access private members from within the class itself and not the subclass or outside. Let me show you my example of a real-world use. Obviously this isn't the strongest code for encryption, but hopefully this can give you an idea for uses of the private members. From this code, I've created a class that will take an input for an attempt at a password. We have the attribute for what the password is, and it is a private member set to hello123. We can use the private member since we are inside the class itself and use it to test if the attempt is the same as the password. It will print if it is or not. So now we're going to put in 2 attempts. First we try hello134. This will be put as incorrect. Then we will try hello123 and this will return the password is correct. We can ask for what the second attempt was by printing it, but then I will try to see what the password is, and once again it will come up with an attribute error. I hope this all makes sense, and if you have any questions, be sure to ask them in the comments. Now on to my final topic of today. Python is polymorphic, meaning we can access objects of different types through the same interface. An example of polymorphism would be a class called vehicles, and then a subclass called lorries, for example. All vehicles will have wheels and seats, but maybe for a lorry you would like to add in a load. Here is how you go about writing that out. So for all vehicles we have seats and wheels. Therefore, in the vehicles superclass, we're going to receive the attributes seats and wheels. Perfect. So let's get more specific now with the subclasses. Let's start off with cars. We make a class, set it to the subclass of vehicles. We then initialize to receive the seats and wheels, and now the amount of passengers. So we first send the seats and wheels to the superclass for initialization, and then we can put a new attribute for passengers. Let's do the same for buses with capacity. We will do lorries and place a load attribute on. So now we have got 3 potential classes with 3 attributes each, but because of the superclass, we only had to define the seats and wheels attributes once, therefore making our code more efficient and can save time in the long run. You can see we define 3 objects for the different subclasses by just doing it as usual. Perfect. So that is how we use polymorphism. Now we have reached the conclusion of this video. So like always, we're going to put your knowledge to the test. What is an object? What is a method? What is a private and protected member? And what does the super function do? Amazing. The answers to these will be in the comments, so make sure to comment how you did. I hope you practice everything you have learnt today. The code I have used for today's video is up on GitHub, so make sure to check that out. Next video, we will be diving into data structures, so make sure to keep an eye out for that. But thank you so much for watching this video. I really hope you enjoyed and learnt something. Hit the like button and subscribe to support my channel, and click the notification bell so you know when the next video drops. Thanks again for watching and enjoy the rest of your day.